Hello friends, welcome to BSc second year. Now, last year we have studied two papers, but this year we have to study three papers in mathematics. I have sent you the syllabus already. You refer the syllabus, and the papers are MAT 301 number theory, then MAT 302 integral transforms, and MAT 303 mechanics part first. So these are the papers for the third semester. Today we shall start the paper MAT 301 number theory. In this paper, the first chapter is divisibility theory in the integers. Then we shall study the prime numbers in this paper, and further we shall study congruences, Fermat's theorem and Euler's pi function, etc. We shall study in the number theory paper. Now divisibility we have studied already in our school mathematics. A number divides the another number, and then we know usual procedure of division. For example, suppose 27 is divided by a number 4. Then what is the quotient here? The divisor first apparently you see is 6, and the product of 4 and 6 is 24. We subtract this 24 from 27 and we get 3. Now this is a simple division process. If the number is exactly divisible by 4, we have the remainder will be 0, otherwise the remainder is non-zero. Now here this number is called dividend, this is divisor, this is quotient, and this is remainder. So we will denote these numbers, we shall denote this number 27 by B, or we will denote this by A. We will denote this number 4 by B, and this quotient we denote by Q, and this remainder we denote by R. So this is the notation. There are different numbers and these are denoted by these letters. Actually we have divided 27 by 4 and we obtained 6 as the quotient, 3 as the remainder. Now this expression can be written as 27 is equal to 6 into 4 plus 3. This number 27 is 6 into 4 plus 3. Now you can check it. So and this property of this remainder is, the remainder is either 0 or less than the divisor 4. So that means this 3 lies between 0 and 4. So we write here 0 less than or equal to 3 is less than 4. Actually this is 0 is less than 3 is less than 4. And now we can write this as in terms of the letters. Now you see 27 is A, what is 6 is Q, and this 4 is B plus R, and 0 is less than or equal to R is less than B. 3 is R and 4 is B. So this procedure, which is very simple, and we always use this to divide one integer by another integer and obtain quotient and remainder. Is the procedure is called division algorithm or division process. The process of algorithm is a systematic process, step by step process, and thus this is known as division algorithm. Now we shall state the division algorithm and we shall do it. It is a theorem. See, given integers a and b with b greater than 0, there exists unique integers q and r such that or satisfy a is equal to qb plus r. 0 is less than or equal to r is less than b. Same result we have written in the form of theorem. Any two integers a and b, but the condition is we in this theorem we have considered b is greater than 0, that is b is positive integer, a is any integer, may be positive, may be negative, may also be 0, but b is strictly greater than 0 means b is positive. There exist unique integers, unique means only one, integers q and r such that a is expressed as qb plus r and r lies between this. 0 is less than or equal to r is less than b. Now in this theorem we say q and r are quotient and remainder when a is divided by b. So the proof here, we shall prove the theorem, division algorithm, and the process is very simple. Now we shall prove the division algorithm. We construct the set S as S is the set having numbers in the form a minus xb such that x is an integer a minus xb greater than or equal to 0. Such type of set we shall construct, and now you see a, b are the integers, any integers, x is also integer, and we are studying only integers, no fractional number. So first we shall prove that this set S is non-empty. So we shall prove that S is non-empty. That means S must contain at least one element. Then it will be non-empty. So for that purpose, we will consider C, B is greater than 0. So we have B greater than 0, and therefore B is greater than or equal to 1. Greater than 0 means 1 or more. And therefore, if you multiply both sides by absolute value of A, mod A into B is greater than or equal to mod. Now consider A minus in bracket minus mod A into B. this is equal to, consider this type of expression, a minus, here actually we have considered in this form, a minus xb, x is taken as minus mod a, and this will be equal to a minus of minus will be plus a plus mod a into b. Now we have mod a into b is greater than or equal to a, so therefore we replace this by mod a, and the relation will be greater than or equal to. So that is, we are adding a on both sides, a plus mod a plus mod a, and a plus mod a is greater than or equal to 0, because the mod a has two values, possible values, minus a or plus a, and if it is minus a then this will be 0, if it is plus a positive then it is greater than 0. So therefore this value is greater than or equal to 0, and that means this value lies in this set. So what is the condition? A minus xb, the number must be of this form, a minus xb, and it is greater than or equal to 0. So this number is in the form and which is greater than or equal to 0. So therefore for the choice of x equal to minus mod a, this number belongs to S. A minus mod a into b belongs to S. Therefore S is non-empty. S is a non-empty set of non-negative integers. Non-negative means greater than or equal to 0. So thus we have constructed set S, and we have obtained result as it is non-empty and it is having non-negative integers. Now if such type of set is there S, then it will have the least element. So for example, if S is a set of non-empty, it is a non-empty set of non-negative. Non-negative means 0 or greater integers. So then it will have a least element. For example, S is having these elements, say 8, 7, 10, 12, 3, 5, 1, 11. For example, so this what type of set it is? Now it is a set of non-negative integers. Now the property of this set is it has the least element. Now we can observe and we can find out which is the least element. Now you may see here the least element is obviously 1. So thus we can order the elements in increasing order or decreasing order, and if you order increasing order, then the first element will be the least. So this is the property of this set also. It will have the least element, and the principle is known as well ordering principle. By the well ordering principle, S has the least element. Say R. Suppose it is R. Now, if element of S is R, then R must be of this form a minus xb. X is integer, so instead of x we may denote the integer by another letter q. So by definition of S, there exists or there is an integer q such that R is equal to a minus q, and this R is element of S, therefore it must be greater than or equal to 0. Now from this we can write A is equal. So what will be A? Will be, take this QB on other side, QB plus R, and condition is R is greater than or equal to 0 means 0 is less than or equal to R. Now see, we have obtained some part of the result. We have to prove that A is equal to QB plus R and 0 is less than or equal to R is less than B. So that is all. So what is remaining to prove is now R is less than B. So that part we shall now prove. So we shall prove that R is less than B. Now we will consider it in indirect way. Now if R is not B, this is not true, then what will be the case? R will be greater than or equal to B. If this is not the case, or if this is not true, then R is greater than or equal to B. Negation of this. R less than B, opposite of that, negative of that is R is greater than or equal to B. Now we will have like this. A minus Q plus 1 times B. So consider the number in the same form, A minus XB. X is here, Q plus 1. So how will you write this? A minus Q into B, and next is minus B. Now you see, what is A minus Q into B? It is R. So therefore this number is R minus B. Now you see, R minus B. R is greater than or equal to B. So R minus B will be greater than or equal to 0. And what this shows, this number A minus Q plus 1 times B is in S. It is of the form A minus XB and A minus XB. So therefore this number is in S. And again also R minus B. A minus Q plus 1 times B is equal to R minus B, and this is less than R. R minus B is less than R. R minus some positive integer will be certainly less than R, because B is greater than or equal to 1. Or the reason will be written as B greater than or equal to 1. And what now this says? So this shows that the number A minus Q plus 1 times B is in R, is in S, and it is less than R. This number is in S or belongs to S, and it is less than R. So the above statement shows it is in S, and the below statement shows it is less than R. Now this is a contradiction. So why it is a contradiction? Because R is the least number in S. R is the least number or least member of S. So we have written by well ordering principle, S has the least element R. So no number less than R will be in S. So this is a contradiction. This is a contradiction to the choice of R. To the choice of R as the least element of S. And thus our supposition that R is greater than or equal to B must be wrong. Therefore we must have, if we assume R greater than or equal to B, we get a contradiction. So that means this must be wrong, and means this must be true. Thus R is less than B. Thus we have r less than 2. Now we combine this condition with this statement. We suppose this as 1. Therefore, from 1 we have A is equal to QB plus R. 0 less than or equal to R less than B. Now we obtain the same condition as in the division algorithm. A is equal to QB plus R. 0 less than or equal to R is less than B. But yet the proof is not complete. Now what is remaining to prove is the uniqueness. Now in the theorem we have stated the integers are unique. That means Q and R here are unique. There is no other pair than only 1. So we shall prove it as uniqueness. Uniqueness of Q and R. And for this purpose, unique means only one integer. Now we will assume there are two. Suppose there is another pair, Q dash and R dash, satisfying the same condition. Suppose A has two expressions. As A is equal to QB plus R, and that is also equal to Q dash B plus R dash. So it can be written as in two ways. That means Q and R are not unique. There are other values also, where